Hello class, welcome to today's lesson. Our topic for today is Cartesian coordinate system. When you talk about Cartesian coordinate system, it's a method of locating a point or graphing an algebraic function using a set of real numbers that we call coordinates. So we're talking about the coordinate system. We have the two-dimensional coordinate system, which is called 2D coordinate system. We also have the three-dimensional coordinate system, which is called the 3D coordinate system. So for the two-dimensional coordinate system, we know that we are dealing with two axes. So we have something like this, the x-axis and the y-axis. So we locate a point here, we have like x, comma y, and we are locating about 2 points. This becomes x1, y1. And when you locate another point, it becomes x2, y2. So we can locate points on the Cartesian plane. Then for the three-dimensional coordinate system, so we'll be dealing with three axes. We have the x, the y, and the z axis. So this is the third one, the z. And then if we locate a point, then we locate the point. So we have x, y, z. So like earlier stated, I said the coordinate system is used to locate points and also used to draw graphs for various algebraic functions. So we can also use it to write formula for distance between 2 points. We know that formula for distance between 2 points is d equals to square root of x2 plus x1 square plus y2 minus x2 minus x1 square plus y2 minus y1 square. So this one can work for the two-dimensional Cartesian system, but if you're talking about the three-dimensional, then it becomes ineffective. So we introduce another formula for distance between 2 points on the three-dimensional Cartesian plane. So here we have x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. So when we get the figure for everything inside these braces, we can now get the square root. So the square root covers it all. And then to get midpoint of a line, let's say you're given coordinate x in a two-dimensional plane. Yes, so if you have to coordinate, for example, now you have 2 points. This is x1, comma x2, and then you have another x1, comma y1, and then you have another one x2, comma y2. So to get the distance between the 2 points, you can now get, sorry, to get the midpoint actually, the midpoint of this line, let's say line cuts across this. So to get the midpoint of this line, we have midpoint x, comma y is equal to x1 plus x2 over 2, comma y1 plus y2 all over 2. So that gives us the midpoint. So you have this point on the Cartesian plane minus 1, comma 4, and then you have another point 5, comma 6. So we want to get the midpoint, we pick x1, this is y1, x2, y2. So the midpoint x, comma y will now be minus 1 plus 5 divided by 2, comma 4 plus 6 divided by 2. So this gives us minus 1 plus 5 is 4 over 2, 4 plus 6 is 10 over 2. So the midpoint is 2, comma 5. Now we can also represent complex numbers on the Cartesian plane. Normally we know that this is the form of a complex number. A complex number usually takes this form. Z equals a plus ib, where this is the real part and this is the imaginary part. Now we know that to represent numbers on the Cartesian plane, we've been dealing with real number system. But for complex numbers, we're going to deal with this. The x-axis will be the real part and the y-axis will be the imaginary part. So for instance, if we are asked to represent this complex number 2 plus 3i, For the Cartesian plane, we have 1, 2, 3, 0, minus 1, minus 2, minus 3, minus I, minus 2I, 1I, 2I, 3I. So we have 2 plus 3I. This is the real part. We go to the real part. This is the real axis, P2. So this is 2. And then the imaginary part, we have 3I. We go to 3I. So we trace it down to where we have 2. We trace this one up to where we have 3I. So we have represented this complex number on the Cartesian plane. So this becomes 2 plus 3 at this point. It's 2 plus 3I. So we have come to the end of this lesson, and I hope to see you in the next class. Bye for now.